These are some fast slews that I'm testing with the new mount. Still in its test setup configuration. These are 120 degree per second slews. And this goes 0 to 90 degrees and back and tracks to get to within 5 arc seconds in 1 second to go 90 degrees. And here's the evidence for that, this dotted line here. So that's position, going up, waiting, and then down. And this is the error band of 500 counts of this 26-bit encoder, which is about 5 or 6 arc seconds. And there you can see where it settles after a second. So yeah, when you have a small payload like that and this mid-size motor, you can get really high performance for fast slews. So here we have a design concept for an all-weather installation that requires no dome. It has 2 telescopes in a tandem arrangement. It's intended for public viewing. It supports both a one person looking through a telescope or imaging, has a camera that's built in, or the 2 setups where 2 people can view or one person can image and another person can be viewing the same target. The advantage of direct drive here is there is no risk of damaging the telescope by somebody pushing on it. It has absolute encoders, so it has high accuracy with no initialization. It always knows where it is, so it's very resistant to abuse. Can't really be damaged by pushing on it. It has safety features, low force for slewing, so it won't hurt anybody when it's slewing, and multiple telescopes can be controlled from a common interface. So it's a great kind of opportunity for that type of installation. We just want to have a lot of telescopes. You want to have minimal setup, instant on. Basically, as soon as it's turned on, the telescope knows where it's pointed and can point to a number of interesting objects in the sky, and people can image them, just like you would do with any smart telescope on the market today.